Hello, this is Jacob from the Gitaly team, and in this video I want to give some background for whoever's reviewing my merge request with the backfile analyzer about what's going on here. So this merge request adds some subcommands to gitaly-debug that print metadata that you can find in a backfile bitmap file. And I created this code because I could find very little out there that could tell me what is actually going on inside a bitmap file. So first, let's look at what this bitmap file is. There's documentation in the Git repository where there's a file about the bitmap format that explains what is in the .bitmap file. Right. So what's the .bitmap file? Here I have checkout of GitLab, a clone of GitLab Community Edition, and if we look in the objects directory, then we have a back file, an IDX file, and a bitmap file. The bitmap file wasn't there. The bitmap file isn't there if you do a clone. I had to create it with git repack, and it's something we use on the server side in GitLab to accelerate to make clones perform better. So I wanted to understand what is actually in this bitmap file, and this thing on the left here is all I had. So this is a description of the file format. So what does it say? There's a header, there's some flags, there is a number of entries, bitmap commits, in the header. Then there are 4 bitmaps that provide information about the types of the objects in the back file. And then this number of these entries that were mentioned before start. And each of these entries is a bitmap that contains information about which objects are reachable from that particular commit. And then at the end of the file, there's an optional section with the name hashcache, or the so-called bitmap hashcache, which is an optimization for to help with delta compression. I didn't look into this because it's why didn't I look into this? Because I was more interested in the reachability than in delta compression. Also, this thing is off by default. So, why do we need this information in the first place? Well, a back file is just a stream of Git objects with length prefixes. So if you want to find an object in a back file, you need to start at the beginning of the back file and then jump from one object to the next until you found the thing you were looking for. So that's actually a very horrible way to find objects. So a back file on its own is pretty much useless without an IDX file, which contains a list of all the object identifiers, the Git SHAs of all the objects in the corresponding pack in alphabetical order, so that you can do binary search on them. And then once you found an object ID, it gives you an offset inside the back file, so that you can just jump straight to the file you want, to the object you want, and start reading it. So this thing gives you, this is sequential, this gives you random access. Also, this thing doesn't even contain a list of the object IDs that are in there. You have to compute them by reading out object IDs and computing their SHA. This does give you a list of object IDs. So this file is essential. You can't do anything useful without this one. And this file will always be there. When you do a clone, the Git server sends you this file, and your client generates this thing on the fly and stores the two together. So the bitmap is a third file that is optional, that contains information that is not in these two. So the first type of information that's in there, if we start from the top of the bitmap file, are the type indexes. So the index file tells you where each object is in the back file. It doesn't tell you what type it is. It doesn't tell you if, so if I have an object ID, let's see. So here are some object IDs. What is this? Is this a commit? Is this a blob? Is this a tag? Is this a tree? I don't know. Is it Superman? No. So you can only find out what the type is of this object by first looking this thing up in the index and then opening the back file and going to the offset and then reading the first couple, well, really the first byte of the object to see the type. And that means you need that is not ideal if you want to know the type of a lot of objects, because you need to then read it, lots of random different positions in a back file. And that is bad because that all has to get paged in from disk by the operating system. And just for more context, these files are very different in size. The PAC file, this is a clone of GitLab CE, is about 600 megabytes. The index is 41 megabytes. That's still a lot, but it's a lot less. And the bitmap is only 2.7 megabytes. So ideally, if you want to find out metadata about objects, you don't want to load 600 megabytes into memory, be it all at once or by jumping all over the place and forcing it to be paged in. So that's where the type index can be helpful, because you can, if you have the index file and you have an object ID, you can find the type. You can use these two files pretty much, so the IDX file and the bitmap file, to go from an object ID to the object type without having to look in the back file. That is what these 4 bitmaps at the head of the type indexes are for. Now, and then, so that's that. And then there's the bitmap commits. And this is something that I never really understood, which is because I always thought the bitmap is about reachability. And I imagined it as a sort of matrix of all objects. Like for any 2 given objects in the pack, you can see if one is reachable from the other. And that is not that is not the information you get. When the bitmap is created, Git uses a heuristic that I don't fully understand to select a small number of commits as bitmap commits, or what they call indexed commits here. And you get what would have been a single row of the matrix, so for that one commit. So you take that commit and then you look over the entire pack file and you put a 1 for every object. Well, you imagine the entire pack file as all the list of objects in the pack file in pack file order as a long list of bits, and the bits will be 1 if that particular object is reachable and 0 if it's not reachable. So that is what this is in one reachability bitmap for a single commit. So there's a bunch of those in the bitmap file. And one of the questions I had is like, what are these commits? And it's a bit of a letdown, because in the end I don't have a good answer of what these commits are, how they're selected, or if they're interesting, how or why they're interesting. But at least we can find these commits with the tool I wrote. And we can also see this type map, because well, it was a good exercise. It was easier to see if I was parsing the file correctly by parsing this stuff and comparing it with the output of git verify pack, and to see if I got it right and if I got the bitmap parsing code right, because the bitmaps are compressed. So we had to write code that decompresses them. So that's the 2 types of information here. And if we, let's see, I'm in the wrong directory. Right, gitaly-debug is up there. Let's see, so I want to have the normal path, and then I want to have this directory. Can I run gitaly-debug now? Yes. So the new subcommands are the 4 at the bottom here. And the first one is just, the first 2 are based on the type index. So they list the contents of the pack file, and they together with the object types. And there is another way to list the contents of a pack file. That's used the git show index command. So there's another complication here. The IDX file. So The pack file has its own special order for the objects, which is secret sauce of Git pack objects. And I think it is designed to optimize the access patterns so that you have more page cache hits. So for all intents and purposes, this order is somewhat, it's special, and it's not, you cannot predict a priori what this order looks like. You need to know what the repo looks like. For instance, the most recent branch, so the branch commits, the branch heads are at the start of the pack file, and then I think they're ordered by how new they are, or something specific like that. So unless you know what the branch heads were, you don't even know what to expect in this file. The IDX file is very different because it is ordered alphabetically by object ID. So that has a very predictable structure. You don't need to know anything about the objects to understand that how this file is structured. And the funny thing about the bitmap is that so the bitmap talks about reachability and about objects in the pack file, and for the most part it uses the pack file order. So the that's the sort of the perspective that the bitmap format, the bitmap file has on the packed objects. It looks at them in pack file order. So this this subcommand will print the objects in the pack in the pack file order along with the object types. So let's try that. And I'm going to run it in a separate window. List bitmap pack. And that's not going to work. I need to I want to take this and this IDX file and run that. This takes a moment because we're actually looking at a fairly big pack file. This is 600 megabytes, if you may remember, and I can already tell you that there are about 1.5 million objects in here. So the index has 1.5 million entries. The bitmaps, each bitmap in the bitmap file has 1.5 million bits, or up to 1.5 million, and this tool is now printing 1.5 million lines. And this text editor is not very fast, so just the act of printing 1.5 million lines is a little slow. So actually running this command is faster than the bottleneck. This command is now bottlenecked by my text editor. It's like it's running at full CPU. We're in the 1.1 million now, so 1.2 million, getting there, 1.3. Actually, that's the wrong number. That is the pack file offset, and we need to reach 600 megabytes. So this was not a good idea. I want to shut this window. And run this into a file instead. That's going to be much faster. I want to run that into list bitmap pack.txt. So that only took 7 seconds, and this is what you get in that file. The important thing, so what you're seeing here is commit ID, object ID, object type, and byte offset in the .pack file. And this file is sorted by byte offset, so this is the pack file order. Yeah, and for comparison, there's an actually, I'm not going to do that now because I want to move on. But you can do the same. You can get more or less the same output with git verify pack. But on this computer, that will take over a minute to compute roughly the same output we have here compared with 7 seconds for this. And 7 seconds is not the optimal output when using the bitmap because the implementation in gitaly-debug is simplified so you could make it even more performant. Okay, so this is the first subcommand. So I wanted to show what this does. The gimmick is you get this list of object IDs combined with the object types. Here it says commit, but if I scroll down for a while, if I use search, I can find a blob or a tree. Um, so this information in this column is this is what you get from the first part of the bitmap. And there's a second subcommand that I made, which um, prints the same information roughly, but in a more sort of as a visualization. Did I do that right? Yes. And I want to put this into a file named after this. Okay, there we go. So this is a funny visualization I made where we're not printing the object IDs or the offsets, just the object types. And for visual distinctiveness, I chose 4 letters. So capital C for commit, little e for tree, big T for tag, and little b for blob. And so here you see that the pack file starts with a whole lot of commits. And then there's the tags, and then there's more commits. And then it takes a while before we find the first tree. And there's this lone tag here. I don't know why. Then a whole lot of trees that also got selected for some special reason before we ever get to blobs. So now we see some blobs and we see alternating between blobs and trees. And why? Well, this is the dark art of what goes on in Git back objects. So if you want to see the structure, this subcommand lets you see this structure, gives you this visualization of the structure. Now the third subcommand lists the actual entries, the bitmap, the indexed commits. And for this, I want to use a different repo because doing this on GitLab CE is a little slow. It's a very big repo with the 1.5 million commits. So let's get gitaly repo. And let's see, gitaly-debug. So now we don't have a bitmap. I was talking about this, so I need to do a repack. The command I'm running here, if I can find it. A means everything, D means delete back files or delete object files that are no longer needed after you created a new one, and B means create a bitmap. And so here we can see that I think it selected 142 bitmap commits, and that is way less than the number of commits in the repository. And well, that's a nice question, like how many commits are there in the repository? Well, because we have everything packed into one file, we can answer the question of how many commits there are by looking just at this back file. And we know that object types are contained in bitmap. So if I want to know how many commits there are, I need to do gitaly-debug. Come on, without the typo. I want to use this one on the IDX file. And then I want to count the word commits. Apparently there are 3,700 commits in this spec file. That seems low. It seems like a low number. Is that right? We have statistics on the project. Yeah, 3,000 commits. Okay, so that's the number of commits here. So in this clone. But then if we look at the bitmap commits, we're going to get a smaller number. And I'm going to put this in a text file. So it's much faster on a small repo like this, only 200 milliseconds. So it's in here. I clicked the wrong button. 143 lines, and here it said 142 commits, and this first line is a comment, so that checks out. There are 142 bitmap commits. And what so what are these? Let's see, log-1 dash is pretty. This looks like it's a branch, and it is a commit from today. So it looks like this thing selects recent commits. If we do git log -1 dash pretty on this one, then I copy pasted the wrong commit. Go on, there we go. This is a commit from yesterday. So I think this this is we can probably even script this, but I don't feel up to scripting that live. But you can look at these commits like this. Now let's see. So what is that's the third piece of information in gitaly-debug. So we get the bitmap commits, and then the fourth piece of information is that you can select one of these commits and get all the objects that are reachable from it. So let's see, if we take something at the bottom, what is this? That is a commit from 2016. So what is reachable from that commit? That's probably going to be interesting because I suspect that this is a short list of things. So that was the commit ID, and the back, this would be objects back IDX. That is still quite a lot of stuff that is reachable. So, well, here we see the output of the four subcommands. So we have a comment here reminding us what back we're looking at, and what the commit is that we supplied on the command line. So that was 0ed3. Here you go, 0ed3. Well, apparently it is the first object in the back file that is reachable from itself. And then there's a bunch more commits and some trees. Blobs. This list is pretty short. Let's count how big this is. That's 176 lines minus 2 headers. So that means 174 objects. And the total number of objects, did I count that? No. But if I do gitaly-debug, if I run list bitmap back on the index file, and we count that, then there are 30,000 objects. So that last commit in the list only has 174. Was it 174? Yes, 174 out of 30,000 objects that are reachable from it. So this is the sort of information that is in a bitmap file, and how you can get it out with the gitaly-debug tool. And yeah, I think that is I think that is all I wanted to show in this video. So thanks for watching.